Hello friends, I am astrophysicist Devendra Sharma and this is my YouTube channel Astrophysics for You. Dear friends and dear student, today I am discussing very interesting question of the nature of the physics. When you look up at the sky, you see there why sky is blue, why clouds are white, why sometimes rainy clouds are black, and why the sun appears reddish during sunset and sunrise. What might be physics behind these questions? If we want to understand physics behind this question, then we need to understand the electromagnetic spectrum of light. Dear student, electromagnetic spectrum of light is an arrangement of radiation in the increasing or decreasing order of wavelength and respective frequency. As we know that electromagnetic radiation are 7 types. First is radio wave, and second is microwave, third is infrared rays, fourth is visible light, fifth is ultraviolet rays, and sixth is X-rays, and seventh is gamma rays. And these 7 type rays, they have their own property and they have their own application and own uses. For example, radio waves are used for radio communication and radio telecast, and microwave are used in microwave oven. The hot bodies produce infrared rays. Infrared rays is a sensation of heat. And then visible light. Visible light is that light through which we can view and we can see everything. We can see this beautiful world around us. This is just because of the visible light. And then ultraviolet rays. A sun is a great source of ultraviolet rays, and ultraviolet rays is very dangerous for human skin. It can cause cancer. And then X-rays. X-rays are the rays which are very useful for the medical purpose. And lastly, the gamma rays. Gamma rays are used for cancer treatment. Now let's look at the increasing or decreasing order of wavelength and frequency of these electromagnetic radiation. First, let me tell you that the wavelength increased from gamma rays to radio wave. As we move from gamma rays to radio waves, toward radio waves, wavelength get increased and the frequency get decreased. Means that gamma rays has highest frequency but lowest wavelength, and whereas radio waves has maximum wavelength, longest wavelength and lowest frequency. As we talk about radio waves wavelength varies from 1 millimeter to 10,000 kilometer. This is a range of wavelength of radio waves, 1 millimeter to 10,000 kilometer. And in short, radio waves has longest wavelength and least frequency, whereas when we move from radio waves to gamma rays, then gamma rays has highest frequency, highest energy but lowest wavelength. These are the basic to understand the interesting question of the physics. And in these electromagnetic spectra, in the between there is a visible light. Visible light further consists of 7 colors. Visible light has their own spectrum. This visible light consists of 7 colors, and as we move from violet to red color, the wavelength get increased whereas frequency get decreased. Means that red color has longest wavelength and shortest frequency, whereas violet color has highest frequency and lowest wavelength. The wavelength varies from 400 nanometer to 700 nanometer. Violet has 400 nanometer wavelength, whereas red color has 700 nanometer wavelength. After red, there is a orange, yellow, and then green, then blue, indigo, then violet. But as for the longest wavelength and shortest frequency, that is red. So this was all about the electromagnetic spectrum. We will answer all questions on the basis of this electromagnetic spectrum. To keep in mind is that longest wavelength color scatter least, whereas which has the shortest wavelength scatter more. Dear friend, let me explain the first question, that why does sky appear blue? As we know that the rays of light that comes from the sun, the radiation that comes from the sun comes in the form of beam. When these beam of radiation strike our atmosphere, especially at the stratosphere, then stratosphere reflected back these radiation which have shortest wavelength and higher frequency, such as gamma rays, X-rays and UV rays. These radiation are reflected back by the stratosphere, and stratosphere allow only radio waves, visible light and microwaves to enter in the troposphere. Then what happened at the troposphere? The visible light, which consists of sound color, as we know that, as we discussed in the spectrum of visible light, that visible light consists of sound color, and sound color have different wavelength and different frequency. The color that is red has longest wavelength and shortest frequency, scattered least, and the violet color, which have higher frequency and shortest wavelength, violet and blue color has higher frequency and shortest wavelength, scattered more. But fact is that violet light is less produced by the sun as compared to blue light. That's why the scattering of blue light is much more as compared to violet light, and even violet light is not sensitive to human eye. That's why sky appear blue, because scattering of blue light is maximum. Blue light has least wavelength and higher frequency. The light which has least wavelength and higher frequency scattered more. That's why sky appear blue to us. Dear friends, space is black because of absence of scattering of light. There is no air molecule, there is no atmosphere in the space. When the beam of white light comes from the sun, this beam goes as it is. It can't split in different color because there is nothing to scatter the radiation of sun. Hence, if we look towards the sun, we see sun very extremely white and bright. And if we look in the space, there is completely darkness, because the radiation that is coming from the sun, nothing to scatter this radiation, hence we can see nothing. We see only darkness and complete darkness. Hence space is black. Dear friends and dear students, don't skip the video. This is the demonstration for that space is black. Friends, this is source of light. We can assume it as a sun because there is no dust particle in space, there is no atmosphere in space. That's why we can see only the sun. So this is demonstration how light can be scattered from the dust particles and from the gases in the space. If there will be dust particle, if there will be atmosphere, gases in the space, then the path of sunlight become visible. And this is white. So friend, this demonstration proved that if there will be gases, there will be dust particle in the space, then the light of that is coming out from the sun can be scattered by these particles, these gases, which we can assume here. So this was the demonstration to prove that the presence of atmosphere, presence of particle in the space can scatter the light that is coming from the sun. Thank you. Now friends, let me explain the third most important question, is that why sun appear reddish during sunset and sunrise. This is just because of the scattering of light. As you know that, as we know that we have studied in light spectra, visible light spectra, that the color of light which has longest wavelength and shortest frequency travel much larger distance as compared to the color of light which has shortest wavelength and higher frequency, because the light color which has shortest wavelength and higher frequency scattered more. They can't travel long distance such as the red color travel much larger distance because it has longest wavelength and shortest frequency. That's why during sunset and sunrise we see reddish around the sun, and sun itself appear to be red in color and orange in color. This is just because red light, orange light and yellow light can travel much larger distance. It has longer wavelength, hence we see a reddish color of sun during sunset and sunrise. And similarly, there is one question similar to previous question, is that why sun appear white during noon? This is because of during noon sun is just overhead. It has traveled much smaller distance. The light rays that is coming from the sun has to travel much smaller distance. It means that there will be a small probability of scattering of light. If there will be small probability of scattering light, which means that neither blue color is scattering nor red color is scattering, and all the color of light will be coming toward us in single form of beam, because it is a principle that the presence of all color in a single beam appear to be white. That's why sun appear white during noon when it is just over our head, because its light has to travel much smaller distance. Dear student, last question is that why clouds are generally white, but sometimes these clouds become dark and black? This is just because of the phenomena that is related to light, as we have discussed earlier. Now let me tell you that when rays of light falls on the water droplets and dust particle, because clouds are made up of majority of water droplets and a small amount of dust particle. As we know that the size of water droplets and dust particle are much bigger than the size of wavelength of visible light. When visible light strike these dust particle and water droplets, they scattered all the color of that visible light in equal manner. Hence, when they scattered all the color in equal manner, then it produced white light, and we see these clouds white. But sometimes why these white clouds become black in rainy days? This is of big size and very thicker, and when we see from the earth clouds, they are black, because we are seeing that portion of the cloud up to which light cannot penetrate. This is just because sun rays cannot penetrate the whole thickness of the clouds. Sun rays just strike the upper layer of the clouds. When you will fly in an aeroplane above the clouds, then you will see that there is no dark cloud, and you will see there is white cloud, because rays of light are striking at the upper surface of the cloud. Because clouds are very thicker, so these rays of light cannot penetrate down to the bottom layer of the clouds. Hence, the bottom layer of clouds become dark and black, but upper layer of clouds remain white. And that's why generally clouds are white in color, because dust particles and water droplets scattered rays of light in equal manner, and these clouds become black, especially on rainy days. This is because of the increasing thickness of that clouds. Sun rays cannot penetrate the whole clouds up to the bottom layer of clouds. Hence we see from the earth that there is a dark cloud, there is a black clouds. This is physics behind this question. Now finally, let me tell you some important points. First point is that water droplets and dust particle are bigger in size as compared to wavelength of visible light. That's why they scattered all the colors of light in equal manner. Related to scattering of light, there is one phenomena that is called Tyndall effect. What is Tyndall effect? Suppose that you are inside a closed room that is dark completely, and a beam of light passing through a pinhole and enter in your dark room, and you will observe that on the path of the rays of light that is coming from a small pinhole, and you will observe that there is a scattering of light from the dust particle that is inside your room. The room is full of dust particles. Dust particles are moving randomly here and there in the room, and when the beam of light passing through a pinhole and enter in a dark room, then these dust particles become visible and the rays of light become visible after scattering from this dust particle. And at that time the rays of light not split in different color, they appear to be white to us, because as I have already told you that dust particles and water droplets are bigger in size as compared to the wavelength of visible light. Hence it scatters all the color, especially these three primary color, red, green and blue, in equal manner. That's why it appears the light that's striking in the dust particle inside the closed and dark room, the light appear to be white and not it's scattered in different colors. So this phenomena is known as Tyndall effect. And one more example is that when there is monsoon in our Himachals, in our areas, a fog formation takes place. When the evaporation of water takes place from the rivers and from the valleys, the formation of fog takes place, and fog rises up and it goes to the mountain, and these fog and that fog appear to be white. This is because this fog made up of water droplets, and water droplets similar to the dust particle scattered the rays of light in equal way, in same way, hence it produced white light. That's why fog appear to be white. For our convenience, we can take just three primary color out of these 7 colors, that is the red color, green color and blue color. These are the 3 primary color, and we can see and we can understand the scattering with respect to only these 3 color. The most important point is that when all the color will scattered, when the all color will reflect from any object or scatter from any object, then it appears to be white, because all colors scatter equally and our eyes get the white image of that object. And when all color of light get absorbed by a particular body, then we see that black. Dear student, in the whole lecture we use 2 basic terms, that is wavelength and frequency. What is wavelength? The distance between 2 crests or trough of a successive wave is called wavelength, whereas frequency is the number of waves passing through a fixed point in a given interval of time is called frequency. So in this lecture we discuss about the electromagnetic spectrum of radiation and the spectrum of visible light, and on the basis of these 2 spectrum we answer the very interesting question that is related to the nature that is happening in our daily life, which we observe, which we see in our daily life. So we will meet very soon. Till then, you take care.